The decibel, expressed in dB, is a clever way to express sound levels, using logarithms to handle the vast range our ears can detect. In this video, we look at where the decibel comes from, why we use it, how it is calculated, and what really happens when two sounds combine. Let's go. First of all, a brief history of the decibel. The decibel, abbreviated as dB, is a unit used to express the ratio between two values. It was developed in the early 20th century by engineers at Bell Telephone Laboratories. The term Bell was created in honor of Alexander Graham Bell, the inventor of the telephone. But because a bell was too large to be practical in most measurements, engineers began using 1/10 of a bell, which became known as the decibel. Now, why we use the decibel? In acoustics, sound pressure can vary across an incredibly wide range. The quietest sound a healthy human ear can detect is about 20 micropascals. That's 0.00002 pascals, just above the threshold of hearing. At the other extreme, the pain threshold can reach pressures of around 20 pascals, which is 1 million times more than the quietest audible sound. If we used a normal linear scale, like watts or pascals, these values would be difficult to manage and compare. The decibel makes things easier by compressing large ranges into manageable numbers using logarithms. And more precisely, we use a logarithm of base 10, also written as log 10, which tells you how many times you need to multiply 10 by itself to reach a certain number. For example, log 10 of 1000 equals 3 because 10 by 10 by 10 equals 1000. So the logarithm is a way to compress very large values, or small ones for some cases, into simpler numbers, which is why it is perfect for measuring sound. In acoustics, we often use decibels to describe the ratio between two sound pressures, two sound powers, or two sound intensities. Now, how sound pressure levels are calculated in decibels. Let's take the most common one, at least for us, the ratio of sound pressures called the sound pressure level in decibels. To calculate it, broadly speaking, we divide the measured sound pressure, called P1 in pascals, by a reference sound pressure value, P0. It is usually 20 micropascals and is considered as the threshold of human hearing. Here is the formula. Now, why 60 dB plus 60 dB isn't equal to 120 dB? To keep this example very simple, we ignore the density of the medium and the speed of sound in this same medium. Since both sources in this example share the same medium, the air, these values remain constant. As a result, they do not affect the intensity calculation and will cancel out during the ratio calculation later. Here is the trick. Decibels are not linear. You can't simply add them like regular numbers because each decibel value is a logarithmic expression of a ratio, the pressure ratio here. Let's break it down. Suppose you have a single sound source measured at 60 dB sound pressure level, SPL, which corresponds to a sound pressure of 20,000 micropascals. Let's call this value LP1. Case 1, the perfect phase alignment, which is very rare. Consider two identical sound waves and are perfectly in phase. Their peaks and dips happen exactly at the same time. Their sound pressures add directly. From there, we calculate the total sound pressure level. So two perfectly aligned 60 dB sounds would result in about 66 dB SPL, leading to a 6 dB increase. Case 2, real-world scenario, incoherent sources and typical cases. In everyday situations, like two people talking, two machines running, or two speakers playing, their sound waves are not perfectly aligned. For sound energy, intensity, of one source, for two identical sources, convert this back to sound pressure, calculate this total sound pressure, and now calculate the SPL. In conclusion, for sound pressure levels, 60 dB plus 60 dB equals 63 dB. Every time you double the energy from equal, independent sound sources, the overall sound pressure level increases by 3 dB because energy is combined, not pressures. For independent sources, not perfectly in phase, the following formula should be used. Thank you for watching this video. If you enjoyed it, don't forget to like it and leave a comment. And if you really like the content, you can subscribe to our channel. It really helps us grow and produce quality content.